Hello, welcome back. This will be our Chapter 4, Part 2. Pick up right where we left off. We were talking about central locations or central theorems, and we were talking about the three M's. Last video covered mean and median, and we're on the third M, which is mode. So here, mode. The mode of a data set is the values that occur with the greatest frequency. So if we had this data set, the mode is 7, right? Because we can see that this data set has 3 7s. It's the number that has the greatest frequency in the set here. So we'd say the mode is 7. Whereas this data set has no mode. So we see that it's 4, 6, 7, 8. Each point only appears once. And we would say this has no mode. No mode. It's the number that has to occur with the greatest frequency. Something also to point out with mode, that most of the time when we're reporting quantitative numbers, remember back to our measurements, our different types of measurements where we have categorical, ordinal, and quantitative. When we have quantitative measurements, most of the time we won't report mode. A lot of times we'll, depending on if the graph is symmetrical or a bell-shaped curve, or if there's skewedness, we might report the median or mean, which could be more appropriate. For mode, the best measure for mode, if you had to pick one, would be nominal data. So if there was nominal data, nominal meaning name or categorical, so categorical data, that is when mode is best used for. So think about like if you were in a class and the class was asking, what is your favorite color, right? A lot of people might report blue or red or whatever as their favorite color. And you can't measure that as a mean or median because you can't put them in an ordered array, right? So we have to report mode as the best measure for this type of data. So mode is best used for nominal or categorical data. So the effective skew in the mean and median mode. So once again, if we look at this, there's kind of more of a graphical representation where if you have a symmetrical mean, median, mode, you'd probably report the mean and mode for symmetrical here. As the graph can be skewed, right, we can have positive, negative skews. Remember to look at your feet for that. So if you have a positive skew, that'd be kind of look like your right foot with the big toe and going down, and negative skew is your left foot with the toe in the middle of your body going to the left, right? So there's your negative skew. And depending on the type of skewness, you probably either report the mean or median. Remember, once again, you only really report mode when it's a categorical data. So spread. Specifically, we're going to be talking about quartiles now. So we have two distributions can be quite different yet have the same mean. And here we have an example of two sites, site 1 and site 2. And you'll see that there is a stem plot here, and it's a side-by-side stem plot where we have our ax multiplier of times 10. So we have values of 22, 24, 28, and then on this side we have 32, 33, 34, just to show you how that works in a review of it. And both these sites have a mean that is approximately 36. But you'll see that site 1, so here we have site 1, exhibits much greater variability, right? So because we start down here from 22 and it can go all the way to 68. Whereas in site 2, the lowest value is 32 and the greatest value is 40. So there's more variability on site 1 and than on site 2. And if we just look at the means, right, we would say, well, their sample here is the same. Well, without looking at the data, we would, we might be misled. But we would see that if we didn't have this high pollution day here, we might not have the same mean. So we have to sometimes look at the spread with all the information that we're looking at, right? The location spread. And now we're going to be getting into the quartiles and dividing this up and getting a little bit more information out of it. And when we divide it up, we're going to from spread, we're going to be talking about range. So range is equal to the maximum value minus the minimum value. Don't be confused with spread. Spread is just reporting the minimum to the maximum, right? Remember, we're spreading A peanut butter and jelly sandwich, we want to make sure it's all over the slice of bread we have. So we're going to report from the bottom to the top. Whereas the range is going to be the maximum value minus the minimum value. So here we have site 1 and site 2 again. So our example of reporting range is site 1, we have from 68 all the way to 22, so 68 minus 2 is 48. Site 2's range is from 40 minus 32, which the range is 8 there. Beware, the sample range will tend to underestimate the population range. Always supplement the range with at least one additional measure of spread, right? We don't always just want to report just the range of a data set we have. We want to give it some other measurement of spread as well. And what we can do for that is quartiles. So we have what's called first up quartile 1, which cuts off the bottom quarter of the data from the median of the lower half of the data set. And then quartile 3, which cuts off the top quarter of the data, median in the upper half of the data set, and the interquartile range, also known as IQR, which is the Q3 minus Q1, and it covers the middle 50% of the distribution. So let's see what that looks like with a data set here. So we have our age data set that we've been using for a while now. So we have from 5 to 52. Remember, that is the spread. And if we want to find the median, which we did earlier, it would be the n depth, and we meant our n depth was going to be 5.5, which then means our median value was going to be here, which is going to be 27.5. Now, when we're trying to find our Q1, it cuts off the bottom quarter of the data, which is equal to the median of the lower half of the data set. So imagine we have this data set, now we're cutting in half, right? We have equal parts on each side. We have 50% of the distribution here and 50% of the distribution here. Well, what we want to do is imagine like we have $1, or we have quarters, right? We have 2 halves now, and now we want to find the first quarter and the third quarter of the data set. So if we have half and we take another half, that will be where the first quartile is, the first quarter. So we have our data set cut in half, and we have these 5 values here. And we want to cut this in half. So if we wanted to do our n plus, to find the depth, we can do our n plus 1 over 2 to find the depth. And if our n here for this data set is 5, we do 5 plus 1 divided by 2. So 6 over 2 is going to equal 3. And if we go 3, the depth of 3 in, right, 1, 2, 3, we find the value of 21, right, which is the middle of this bottom half here. And we'd say quartile 1 is equal to 21. Same thing for the top half. We have our 5 digits, and we're going to split that in half, and our value here is going to be 42. That's our Q3. So when you think about our median is going to be the 50% mark, and then our Q3, if you want to think about it, is the 75% mark, and this is the 25th% mark. So we're just finding these quartiles, right? Quarters, remember the dollar, so we're just finding these quartiles within our data set. And then to find the IQR, we take our Q3 minus our Q1. So it's shown here, IQR is going to be our Q3, which is 42, minus 21 equals 21. So IQR equals 21. Knowing this, there's a certain rule we need to follow. Certain statistics classes will do something different, and some calculators will also do something different, but we're going to be following what's called Tukey's hinges. So here we have an example 2, and we have metabolic rates of calories per day, and our n equals 7. So here we have our median. We've done a data set like this similar, and we have our median of 1614. Now, when we're trying to calculate our Q1 and Q3, we're going to cut the data set in half, but Tukey's hinges is going to state that we include the medians in both halves. So we know the median is here at 1614. Since it lands on a specific number, we are going to use that median in both halves. So that means our first half of data is going to look like this, and then our which is shown here, 1362, 1439, 1416, 1614. And then our second half of the data is going to be including the median in this part. So it's going to be from 1614 all the way to 1867. That's going to be your Q3. And when you do this, you're going to do the same thing. You're going to find the middle value of the lower and upper halves of the data set. And then since this value is going to fall between two numbers, you're going to average those two numbers out. So for the bottom half, we're going to average out between 1439 and 1416. We're going to get a value of 1449.5. And the top half, we're going to value 1666 and 1792, which then gives us a median value of 1729. Moving on, so now we have the 5-point summary. So our 5-point summary is everything we've just talked about, which is Q0, Q1, Q2, Q3, Q4. We've talked about all these. And if you think about this, Q0 and Q4 are the minimum and the maximum values, right? This is also equal to the spread. The spread of a data set will tell you your Q0 and Q4, the minimum and maximum, right? And then we just did the Q1, Q2, and Q3. And we found this by finding the median and then going from the median, dividing our data set into two halves, and then finding the middle value between those two halves, which would then, of the lower half would be the 25th percentile, and then the upper half would be the 75th percentile. And this is your Q 0, 1, 2, 3, and 4. So this is what's called the 5-point summary. It's everything we just went over, but it points everything out to you very simple and clearly. From this 5-point summary, we can then make what's called a box plot. And in this box plot, we have to first calculate a 5-point summary, which we've done with a couple of these examples. And then with the 5-point summary, basically you will draw a box from Q1 to Q3 with a line at the median, and then you will calculate your IQR and fences as followed. So you will find your fence lower, which is equal to your Q1 minus 1.5 times the IQR, or your upper fence, which is Q3 plus 1.5 times the IQR. You don't draw these fences. These fences are here to determine if there's outliers in your data set. We'll talk about that in a little bit more detail coming up here. After you determine your fences, and you're going to find if a value falls outside of these values. So if you're on an upper fence, it would have to be greater than the upper fence, right? It would have to be a greater than that. If it's lower, it's going to be less. It's going to be less than that value. And I'll show you an example coming up here. And if there are outside values, you plot these separately. You determine the value of the inside fences, and then you draw your whiskers from Q3 to the upper inside value, and you draw your whiskers from Q1 to the lower inside value. So here we have an illustrated example of a box plot. This is what I'm going to do. I'm running close on time, and I don't have enough to get through all the box plot examples here. So here is a box plot. Our example is going to be a box plot. Here's our data that we've done before, and we've done finding the median for this, and you know what the spread is. Find the 5-point summary for this, and once we get the 5-point summary, come back and we'll start the next video going over this example box plot for you. All right, I will see you in the next video then.